Binary number systems. Before we jump into binary, let's quickly revisit the decimal system, the one we're most familiar with. In the decimal system, we have 10 digits, 0 through 9. Each digit's position represents a power of 10. For instance, in the number 238, the 2 is in the hundreds place, the 3 is in the tens place, and the 8 is in the ones place. Now, let's introduce the binary system. Unlike the decimal system, which has 10 digits, binary uses only 2 digits, 0 and 1. Each digit's position represents a power of 2. For example, in the binary number 101, the leftmost 1 represents 2 power 2, the middle 0 represents 2 power 1, and the rightmost 1 represents 2 power 0. Adding these values together gives us a total of 5. Sign magnitude representation. Sign magnitude representation is a method used in digital logic and computer systems to represent signed numbers. It is one of the simplest ways to represent both positive and negative integers using a fixed number of bits. In sign magnitude representation, the leftmost bit indicates the sign of the number, where 0 represents a positive number and 1 represents a negative number. In sign magnitude representation, the leftmost bit indicates the sign of the number, where 0 represents a positive number and 1 represents a negative number. The remaining bits represent the magnitude of the number itself. Sign bit. This bit determines the sign of the number. If the sign bit is 0, the number is positive. If the sign bit is 1, the number is negative. Magnitude bits. The rest of the bits in the representation are used to represent the magnitude of the number. These bits follow the standard binary representation. Disadvantage of sign magnitude representation. Non-unique representation of 0. In sign magnitude representation, both 0000 and 1000 represent 0. This can lead to complications in arithmetic operations and comparisons. Ones complement representation. In digital logic and computer systems, the ones complement representation is a method of representing signed integers using binary notation. It's an alternative to the more common twos complement representation. The ones complement representation has both positive and negative values, and it involves flipping the bits of a positive binary number to represent its negative counterpart. Steps involved in calculating ones complement. Start with the binary representation of the number you want to convert to ones complement. Flip all the bits, changing zeros to ones and ones to zeros. The resulting binary number is the ones complement representation of the original number. Properties of ones complement representation. There are two representations for 0, 0000 and 1111. This is because the ones complement of 0000 is 1111, and vice versa. The range of representable numbers is from 1 to plus 1, where n is the number of bits. For example, in a 4-bit system, the range is from -7 to +7. Arithmetic operations in ones complement can be more complex compared to twos complement, especially for subtraction. Overflow can occur in certain cases due to the two representations of 0. Today, we've embarked on a journey through the fascinating world of binary, from its fundamental principles to its pivotal role in modern computing. As you continue to explore the digital realm, remember that every image, sound, and piece of information you encounter is ultimately represented and processed using binary code. If you enjoyed this video and found it enlightening, don't forget to hit that like button and share it with fellow curious minds. For more captivating content and educational explorations, make sure to subscribe to our channel. Thank you for joining me today, and remember, the binary world is yours to decode. Until next time, keep embracing the wonders of knowledge and keep those ones and zeros dancing.